Noise in color images. All the noise models that we discussed a few weeks ago are applicable to color images as well. Typically, noise affects all color channels, all color components. And usually across the color channels, the noise is independent and its statistical characteristics are identical. So if you want to build a color model, it's usually enough to analyze one channel and apply the same correction to all three channels. However, due to different illumination conditions or selective malfunction of the camera hardware in a particular channel, this may not be the case, so it's always good to investigate all the channels that we have. Noise filtering by means of simple averaging can be accomplished by performing the operation independently on RGB, if you are dealing with RGB space, and then combine the results in the end. But more complicated filters, such as the median filter, they are more involving to formulate an operation that's going to work on the three channels independently. This is an example of Gaussian noise on the red, green, and blue channel. You can see, and this is the final result, right? This is the final result of noise in the R, G, and B channel. You can see that the noise is pretty much a standard thing. It's spread out evenly and has this. It seems like to have the same statistical characteristics. So, in order to create a noise model, just a quick recollection about the one of the previous lectures. You get a slice of this image, build a histogram of this part, see what kind of noise it is. In this case, the book inserted Gaussian noise, so it's going to be something like this, right? Your histogram is going to be something like this, where you can extract from that the mean and the standard deviation. Then you create your Gaussian and you apply a filter on a Gaussian filter to every one of these channels, and and then at the end you combine them all into a better image, right? Into a corrected image. The same thing you can do on the HSI components. As you can see here, this is an image that's been, the hue is, there's noise corruption in the hue, in the saturation, and not so much on the intensity. So in this case, you may want to apply different filters on the hue and on the saturation and on the intensity independently, and then combine these three channels in your final result. This is an RGB image corrupted by salt and pepper noise in color. So you can see that you can see red and green dots here on the final image, but these are generated by salt and pepper in each one of the red, green, and blue components. The RGB. Oh, sorry. This is the RGB image with the green plane, only the green plane corrupted by salt and pepper. And this is the hue component of an HSI image, and this is the saturation component, and this is the intensity component, also corrupted by the same kind of salt and pepper noise. And that's all what I had to talk about noise in color images, which basically it's everything that we discussed in the in the lecture about noise models in the intensity levels in the grayscale image. And I'd like to close this lecture pointing you to this article at The Wire talking about this image from Lena that's been called the patron saint of JPEGs. It's a nice old story. This was a picture taken in 1972. And it became quite famous. You don't see one book on image processing or computer vision that doesn't figure Lena on the part of color image processing. Homework for the week, and especially this homework is essential for your future project. You probably have your project in mind now. I do recommend you to work through this tutorial. Do it all, right? And you can also check a number of other libraries for image manipulation and processing that you can use on your project as well. Some libraries are good for a particular kind of solving a particular kind of problems. Some other libraries solve another set of problems. And this article at Towards Data Science explains in a very general way the various tools available for image processing. Especially Scikit-Image is a great library that we didn't deal with in the labs. We concentrated most of the time in OpenCV, but Scikit-Image is also a part of the tool set, and you can use. And that's one thing that I would also recommend. Get started with manipulating videos. We're gonna have one tutorial about video manipulation, but it's also good to know more because most of your projects, I hope, are gonna be on the on video processing. Which in a nutshell, what is a video? A video is just a sequence of images that are played together in time, right? What is video image processing? You do exactly the same thing that we are doing with a static image, but you apply it at every frame of your image. Depending on the complexity of the processing that you are applying, you may not want to apply to every frame, but to apply to, I don't know, to some frequency every 20 frames or every every fifth frame you apply the processing that you want to apply on the image. Okay, yeah, that's all from chapter 5, right? We're talking about chapter 5, color image processing. The next chapter, that's chapter 6. So next time we're going to be talking about morphological image processing. I'll see you there. Thank you.